My name's Noah Hardwicke, and I'm from the University of Nottingham in the UK. I work part-time for Wolfram Research and have been doing so for just over 2 years, I think. Over those 2 years, I've been working on a new drawing tools project. So we do have a set of drawing tools in the product currently, but it's quite old and it needed to be sort of rewritten and rethought. And so that's what this project is. Okay. Just a brief sort of overview of what I'm going to be talking about. So I sort of quickly want to cover the motivation behind the project and how that sort of informed the design principles. And so I'll just talk very briefly about the UX of the project, because it is a project sort of principally about UX and design. Then I'll talk a bit about how you invoke the drawing tools, which is with a new function called Canvas. And then I'll get into actually sort of, using the tools. So I show you formatting, annotation, drawing from scratch, and finish with then some sort of examples and what we are going to do in the future with this. In terms of motivation, the initial goal was simply just to refactor the existing drawing tools into an attached ribbon. And so if you, in the product at the moment, Control-T brings up the old drawing tools. And as you can see, it's this sort of old style inspector, and you sort of have to manually open and close all the various sections. And of course, when the image tools came along, they set a new precedence for how we do these sorts of tools. And it's, so they attach to an image, and it's a more contextual thing, because obviously it's based on the selection, and when you're focused on the selection, that's when you get those tools. And so, that was sort of just the main objective at first, sort of, put all of this into this. This is obviously a very good opportunity then to just sort of reconsider the whole thing and reconsider the sort of the structure of the tools, so we can do a bit more than just sort of refactor them. And the thing that sort of drove this was, well, we're sort of going in this contextual direction, because they only appear when you select the thing that you want to edit, and so that sort of informed the design principles. And so I'll just very, as I said, very briefly just talk about the UX before I get into actually demoing it. The sort of the main principle that we were sort of working by was, we want to automate as much as possible, and we want to make it as contextual as possible. So we only want to show controls that are relevant to the current selection. That makes it easier to use. It's visually less cluttered. And so if I click, enable dynamics, I should have done that. Okay. And also that's jumping around. I'm just going to quit. Sorry, 1 second. There we go. Okay. Yes, you invoke the drawing tools by essentially wrapping a graphics object in Canvas. But as I said, on the next slide, I'll get on to sort of Canvas in more detail. So these work just like the image tools now. So when you wrap a graphics in a canvas and you have this canvas object, it gives this sort of subtle dotted line just to show you it's something a bit different, something interactable. And essentially what we've done is we've taken all of the primitive insertion tools, for actually drawing new elements into the scene and made those into the ribbon. And then all of the formatting tools are just contained under the selection tab. So for example, I could go and click on one of these and then start drawing something. But actually, if I go ahead and just select that disk, we thought it's fair to assume that if you actually think, if you've selected a primitive, then you're editing the scene, so we can pop open the controls automatically. What you see here is that you have these sort of little pods of controls, and you only see the ones that are relevant to the selection, right? So, this is a filled primitive, so you have, fill and stroke, and you have a range. Obviously, there's only one primitive here, so a range isn't that useful, but you get the idea. We have this saved styles at the top as well, and that's sort of a little feature within itself, so I'll get onto that later. But as you can see, it's a way of, you can save styles here and sort of organize them and then apply them to the selection. But as I say, I'll get onto that. Excuse me. Right. So okay. So you know, here's an example with two different types of primitive. And so, you know, as you'd expect, if I click on the arrow, then I get the controls pertinent to arrows. And also you'll notice that it's not just the different pods that appear, but the pods themselves are some degree of contextual behavior as well. So for example, fill and stroke has now just changed to just stroke. But if I select the disk as well, you know, we're taking the union of those two, of those sets of controls, excuse me. And so, you know, now we get, for example, you know, fill and stroke is going to change the edge of the disk and also the line of the arrow. So yes, okay. So now I will get on to Canvas. So currently, the drawing tools only attach to Canvas objects, and that is because the drawing tools and Canvas itself are experimental features at the moment. The idea with this project is that eventually the drawing tools, you know, much like the image tools attach to any image, the drawing tools will attach to any relevant graphic. So, you know, outputs of plot and things like that. But yeah, they're experimental at the moment, so you have to sort of manually invoke them by wrapping the thing in Canvas. That being said, Canvas itself has some useful features, and so even when, you know, we start attaching it to everything, we will still keep Canvas. Yeah, so there are three ways of interacting with Canvas. One is for editing graphics themselves. So in this case, the entire graphic is selectable and all the primitives in it are editable, like the examples I just showed above. You know, I could actually go and select those individual primitives and change them. And you get that by just simply wrapping the graphic in Canvas. Then there's the second behavior, which is for annotating graphics. And here, the graphic is not selectable nor editable, and it is just used as a background. So it's not, you can't, it's sort of protected. You cannot, it doesn't have to be a graphic. You can actually put anything as the backgrounds, and then you can draw over it, which is quite neat. And I'll show you examples of that later. And then the third thing, Canvas, you can just specify it with no arguments, in which case you get a blank canvas in which you are free to just draw from scratch. And actually that can be quite useful for, we introduce some spline tools into the drawing tools. And so if any of you have used graphics packages like Illustrator or Photoshop, it's essentially the pen tool from them, from those. And it means that you can draw splines from language in a blank canvas, and then you can easily just get that out and use it in, you know, an animation or a graphic or whatever. And again, I'll show an example of that. So let's start with formatting existing graphics. So let's, you know, just, this is a relatively straightforward example. You know what, I'm just going to make that a bit bigger. Image size, let's say 500. Whoops, I put that in the wrong place. Sorry, plots. There we go. Right, so yeah, in terms of actually like formatting what's in a graphic, you know, I've plotted out various, you know, standing modes on a string, for example, of vibration. Let's say I just want to sort of draw attention to one of them. Well, you know, it's, you know, relatively simple. You know, I can just select all the ones that I don't want to see, and you know, we can just make those gray. This is obviously a very simple example just to show you how this is working. Then the one that we do see, it's actually behind some of the others. So let's bring it to the front, and then we can increase the thickness on it as well. And there we go. So that's just a very simple example of formatting what's already in a graphic. So here's something a bit interesting. Because of course you don't have to use the sort of, you know, the background option for annotation. I could of course just start, you know, putting arrows and text and circling things in this. And so I was sort of trying to think of a good example of when you'd want to do that. And actually one did spring to mind. And so a while ago I was giving a presentation, and this code is not really important. What's important is the output. Basically it was, you've got a lattice of ions here, and I'm just giving some indication of how an electron wave function fits in that lattice, just, you know, very rough. But But what I had to do when I did this was sort of, put a frame around this and then sort of manually try and work out, oh, okay, what are the plot points I want for my path? And I had to write them all out manually. So obviously that was, frustrating and a pain. Well, now, if I comment that bit out, I can do that with the spline tool, which is quite neat. So I will go into Polyline. And we've got these nice controls here for drawing splines. They're actually Bezier curves. And so again, as I say, if you're familiar with Illustrator and packages like that, then this will be nothing new. But I'm able to click and drag to change the curvature, as you can see there. And we have controls. Okay. Do not know why that's happening. You can see why this is experimental. Should we try that once more before we give up? Ah, there we go, perfect. And so, you click to place the point and then you drag to move it around. And I won't do any more than that. And then you can, you're able to move the nodes as well, and then go back and change the curvature. So these, we haven't had these tools in Wolfram language before, but we have quite nice graphic capabilities. And so it's quite nice that we have this now. Yeah, I will commit that. There we go. Not a very good wave function. Okay, so let's look at annotation now. So let's just go for a super simple example. And again, actually, I'm just going to stick an image size option here to make this a bit bigger. We go. And so, again, this is just a very simple example. And so, we've got these two tools here, which are sort of, just for circling things and drawing boxes around things. So I suppose I should say, when you click on a primitive insertion tab, you then get the controls pertinent to it underneath. And so, I can circle that intersection with the axis there. And if I go and format it, let's make it red, and let's make it a bit thicker. And then I can also draw an arrow as well. And the arrow, the poly arrow tool, is actually a Bezier arrow, which is quite cool. So I can draw. And remember, I can draw just sort of like an angled one without clicking and dragging. I can just click to place the points. And so there we go. We have a nice arrow there. And if I commit that. And now we also have quite nice controls for editing arrows. And so we have this arrow slider here. In fact, let's make this black so it's a bit clearer. We have sorry, 1 second. There we go, so it's black. And this is actually a slider. And so I can change the position of the arrowhead along the shaft. And I can choose, I can choose custom heads here, and I can add heads as well. Let's have that scaled because there's a bug at the moment. There we go. And so it's just quite a neat way of, building up sort of, very custom arrows, and also got presets as well. So there we go. There's, and obviously if I was so inclined, I could add text, say intersection points, but I'm not going to do that now. So, okay, this is sort of the first, actually kind of interesting bit, which is you can extract the annotation. So let's say you've got a plot that's like non-trivial. And so here's one that I made earlier. This was for a report. I should say that I study physics, by the way, so that's why all these examples are sort of physics related. And so these are emission spectra for black bodies at various different temperatures, and they're Planck curves. And so this is my plot. And let's just get rid of that, we don't need to see it. And so I'm going to use the background option here. And so you can see with the dotted line now, I've got this canvas. And so let's add an annotation here. So let's add an annotation, and let's add some text. I'm going to say that F, I'm going to say that F max is equal to some constant times temperature. And then I'm going to make this a bit bigger with our text tools. There we go. Okay, and you know what? Let's make that arrow black. Now, what if you want to change the plot underneath? Now, obviously, you know, if it's something like just changing the thickness of one of the lines, yeah, you can go ahead and do that with the drawing tools. You would have to use it not with the background option, but you could do that. But let's say I'm not happy with 4,000, 5,000, 6,000, 7,000 Kelvin. I actually want to change it. And so I'm going to, so the input form of what I've drawn is a canvas object, and then the first argument of that is the graphic that I just drew, and then the second argument is the background. So if I say annotation equals first of this, I get the annotation out, and I've assigned that to annotation. So now I'm going to update the plot. And then I'm going to display canvas of annotation, and the background goes to this new plot. And so there, look, see, we've updated the plot. So we've got a different set of Planck curves there, and the annotation has persisted because we were able to save it. So, okay, blank canvas drawing from scratch. So I am running a bit behind, so I'll do this bit very quickly. I think, okay, the best thing to show here is probably the shapes tab. And we have quite a nice shapes tab, and in the future we want to sort of flesh this out a bit, but we've been able to sort of write a tool that will insert any arbitrary primitive into the graphic. And so let's insert this disk here. And now what we've actually inserted is not a disk, but a Bezier curve. And so, you know, we can go ahead and edit this, and so I think, you know, this would be useful for when you want to sort of make some kind of graphic to use in perhaps an animation or perhaps an education visualization where you want something to look nice. I was actually doing a coursework last week where I had to simulate rocket trajectories, and I used this just a blank canvas to draw a little rocket icon, and then dug it out and stuck it into the into the simulation. So it's quite nice to be able to do that completely within Mathematica now, or well, from language, I should say. And I think the last thing I'll show for this is the styles pane. So I said I'd come back to this. So we've got quite a nice way to save and organize and apply styles. So these are the 4 default ones that we supply, and then I've saved a few of my own over here, and then I can add more. And so basically, you know, let's say I want to apply this style, and so that's made it you know, sort of about 50% opacity, I think, and added a solid line to the end. But actually, let's say I'm not quite happy with that. I want that line to be a bit thicker, and let's make it an absolute thickness. I can redefine the style, so I can update it. But obviously there wasn't any text there, so it's got rid of the text. And then, yeah, I can sort of organize these, move them around. You know, I can add them from scratch if I want, yeah, and delete them as well. By the way, you can get rid of them. And if you notice, those first 3 ones there match the the default colors in plot. So yes. Yeah. Okay. Okay. So here we go. Here's a slightly more sort of involved example. I said at the beginning, the option to the background option to Canvas doesn't have to be just the 2D graphics. So this was something I was doing for a project with magnetic resonance imaging. And so what I've got here is, this bit had to be done programmatically, right? And so, these are dipoles in your sample, and usually, obviously, they'd be aligned with the Earth's field, so they'll be pointing upright. And what we've done here is just kick them out of alignment. And if I play this, you can see that they process back around, and then you can pick up that radiation that they're giving off. And the idea is that if I change the field over this, excuse me, you can see that the rate of precession has now changed. And incidentally, that's how you encode spatial information in an MRI image. That's how you do it. So, okay, what I would quite like to do with this is, obviously, we've got this field, and so what there really is a coil going around it to generate that field. I could add that programmatically, but it's a pain. You have to, style everything, and then, nudge it a bit to the left, nudge it a bit to the right. So I just want to be able to draw on this. So what I'm going to do, I've wrapped this here. I've just put a canvas background goes to this drawing. And so what I'm going to do is, if it'll let me, is insert a rectangle. And now, obviously, this is not just a rectangle, this is a Bezier curve as well. And so I can move these points. And so let's move it into the place where a sort of, the core will be on the side. All I want to do here is give some indication on this diagram that there is a coil that's going around this, okay? So I'm going to get it roughly in position there. And then I'm going to use the curvature tool here to curve this, so it's looking sort of like at the edge of a coil. And I'm going to do the same. That's the wrong control point. I'm going to do the same here as well. There we go. Yeah, I'm happy with that. Let's draw that in. And then let's format it as well. So let's make it, let's make the fill so it looks a bit like copper. Let's have an orange fill, and then let's put the stroke as a darker orange, and a little bit of thickness there. Help if I had it on the screen. Okay, perfect, right. So what I can now do with this is if I just deselect this and then select the canvas, I'm going to copy this. So I'm going Command-C on the keyboard, and then when I paste it out, if the background is not a 2D graphic, it just gives you the annotation that you've done. And so there's my annotation. And so now I can assign this to annotation. There we go. I can then say canvas. Hey, that was not what I wanted to do. Annotation. Let's spell it correctly. Come on. Annotation. There we go. And evaluate this. And now, I've just done this very roughly, and obviously you can draw whatever you wanted in here. It's often useful to be able to sort of put 2D elements over things. But now, if I play this is now within that animation, so that's kind of useful. Now, a slightly more involved example, or slightly more useful example, perhaps, of this again is. I'm going to delete those because they may well slow things down. There we go. Is this example, and so this will take a couple minutes. So I don't have time to do it here, but I just want to show you that then this is sort of like a like a real life application, I suppose, of this kind of use of canvas and background. And so because I said the background could be anything, what I constructed programmatically was this animation and this graph, and then the bits that I drew in manually, which would have been a nightmare to kind of do with offset and then try and put the numbers in and then evaluate it and nudge a bit and evaluate, I just use the create canvas. Sorry, use the canvas and drew drew these 2D elements here. So the detection coil, and added this text and added this line, and also this wave, which then I sort of pulled out, put a parameter in, and stuck back in. So I think that's quite a nice example of how this is sort of genuinely quite useful for these animations that you can make. And I'm running out of time. But that is okay because I'm roughly at the end. So future work, obviously, as I've already said, we want to attach this to all relevant graphics. It wouldn't make sense to put this on a graph, but it would make sense to put it on the outputs of plots and things like that. We would like sorry, and obviously part of that is, this is an experimental feature, and so we need to sort of, do some work getting a bit more stable, robustifying it a bit. But what's useful about this project is that it's being deployed as a packlet, so we will be able to update it in the field. We want a richer interface for the style picker, because that is quite a useful feature, being able to save styles. Obviously, they persist over sessions, and so being able to, perhaps sort of expand a bit and, a bit easier to organize. And then I think the sort of the no-brainer as well as a library of shapes, as I said. There's no reason why we can't have basic shapes, flowchart elements, circuit diagram elements, anything really, seeing as we have the capability to just insert any primitive that we want. So yes, and so I'd like to finish on, this is the Drawing Tools team, obviously me as well. So yeah, loads of thanks to these guys, John and Lou, for all their help on the front end stuff, Path for project managing, and Brett has really steered and guided this project over the last 2 years. So thanks guys. I think that is, yep, that is me done with 2 minutes to spare. So I will see if we've got any questions, and we do. I can't see any questions. So if
there were some refresher page, though.
Thank you. Just refreshing. Oh, right, okay, yeah, there's loads. Okay, let's see, let's do these in order. This feature will be in 12.2 as experimental, and as I say, just invoked with create canvas. Can't see anything. Thank you. All the newly added. Yes. It needs. So I'm answering this question about the tech input feature. It does work, but I think the last time I looked at it, it just needed a bit more attention. But it should work, and we should have time to do that hopefully before 12.2 ships. Are the save styles good? Yes, they are. Oh, they are not shareable, but we could make them shareable. But they are global in the sense that they persist, you know, across sessions, across notebooks. You know, close Mathematica down, open it up again, you'll still have them. Yes, they'll be in 12.2. What about, yes, that's a very good question about touchscreens, which we haven't done yet, but yeah, we have a freehand tool as well. Brett's answered that, thank you. Do the text tools support subscripting? That would be useful. Yes, they do. In fact, there are 2 text tools. There are, we've got normal text and we've got math text as well, which you know, formats automatically as a piece of math. 300 reasons. Yes, I agree. Oh yes, you can. You can. That's a global option that we should really put in the drawing tools. I think Zoom is hiding my toolbar at the top here, but oh no, there we go. It is in one of these menus. Snapping is in one of these menus. There we go. Alignment guides enabled. You can do that. Manipulates too. Yes, anything can be the background. Obviously, if you're going to link it to that, you'd have to sort of draw the thing in your canvas and then sort of manually put it in the manipulate, unless you were literally just wanting to draw over it, as I showed with that animate. Interest, that's good, thank you. Great, thank you. Is it possible to draw on top of the whole notebook? No, because you'd have to attach a cell over the whole thing. So no, you wouldn't be able to. And that is time up, and I think that is all of the questions. So thanks everyone for listening. I hope you enjoyed the presentation, and yeah, thanks.